Welcome back. In this video, we're going to get some hands-on practice with vector addition using our previous lecture's example with the rocket trajectory. So I have my project open, and let's set up our practice problem here. Now, in our whiteboard talk in the previous lecture, we had an imaginary character with a rocket launcher, right? And we can visualize that with our debug actors. Now, I still have my DA sniper and my DA victim from our last example. They're still in my level. Now, these two actors are still referenced by our level blueprint. We can open our level blueprint and we can see that we have references to them here. Now, I'd like to remove one of these from my level. If I go ahead and try to do that, such as the victim, if I select it and hit delete, I get a message that says that DA victim is referenced by the level blueprint and other actors/objects. Do you really want to delete it? This will break references. And it shows a reference list. It says that DA victim is referenced by the level blueprint. And of course, it shows that basic map 8 is also referencing it. Basic map 8 is just the actor that owns the level blueprint. Now, we could go back into basic map and delete that reference, and then we wouldn't get this pop-up. But notice we also have the option to just click yes. I'm going to go ahead and do that. Now we've deleted that actor. But if we go back to basic map, we're now referencing an actor that doesn't exist. If I click on compile, I now get a warning. And the node that was our reference to DA victim now says unknown because that actor doesn't exist anymore. And we have compiler results at the bottom showing us a list of the warnings. So upon compilation, the warning says unknown is not referencing a valid level actor. It's smart enough to know that we've gone and deleted that actor. So the way to fix this warning is to simply take this unknown node and delete it. Now we can compile and we don't get any warnings. Now the DA sniper is still in the level. I'm going to go ahead and find that DA sniper. I'm going to click on it in the outliner. And I'm going to rename this because we're now going to use this as our theoretical launcher. So I'm going to rename it to DA launcher. Now, as soon as I do that, I can go back to the basic map, and the basic map doesn't know about that name change yet. But if I go ahead and compile, its name changes to DA launcher. So it's smart enough to update itself. So we now have this launcher. I'm going to position it in my basic map according to our previous practice problem. So I'm going to select it. Now, I don't see it anywhere, so I'm going to press the F key to focus in on it. And I see that it's up here. It's still up at 00700. But in our practice problem on the whiteboard, it was at 220. And here in Unreal Engine, the units are quite small, so I'm going to scale up that position to 200, 200, 0. And I can play test to see that we have our debug actor down here at 200, 200, 0. And we're drawing a debug arrow there. Now I'm going to go back to my basic map, and we see that we have draw debug arrow, and it's starting that arrow at the origin, and that's because we're using get actor location here with self passed in. So what is this self here? Well, every level blueprint is an actor. You can't see it in the level, it's invisible, but it's the actor that owns the level blueprint. So it's not actually the level itself, but rather an actor that's automatically created for the level that has some special capabilities, such as being able to reference instances of other actors in the level. Well, we don't even need get actor location. We can delete that node, and we'll see that drawing at 000, if we press play, gives us the same result. So we have our launcher, and we have its location indicated not only with the debug box, thanks to our debug actor drawing its own location every frame, we also have a debug arrow. Now in our example, we had a direction vector, a vector that represents the trajectory of a rocket. Now we know that we can create variables. We can create variables in an actor class blueprint. We can also create a variable in our level blueprint as well, as we do have a variables section. So if I click plus, I can create a new variable, and I'm going to name this variable rocket trajectory. And this is going to be a vector, so I'm going to open the drop-down and select vector for its type. Now, I want to set its default value, so I'm going to compile first, and then I can give it a default value. So we want our rocket trajectory to be the vector 300, 0, 200 to coincide with our previous whiteboard example where it was 302. Now here's the challenge. We're going to want to find the explosion point of our rocket. In other words, if we take our launcher position, which is down here, and we place our rocket trajectory such that its tail begins at the launcher's position, we want to find the end of that vector. Now, this problem is not as simple as it may seem at face value. You may be tempted to say, well, I can draw a debug sphere using rocket trajectory as the location for it. You might say, let's get a draw debug sphere node, perhaps set its radius to 10, hook it on up with a wire, and then take our rocket trajectory, bring it in, and hook it up for that draw debug sphere center. Well, if you do this, this is actually not the correct answer. And the reason is because this is the tip of the rocket trajectory vector if its tail were at the origin. But we don't want that location. We want the location of the tip of the rocket trajectory vector after placing its tail at the head of the red vector here. In other words, at our debug actor's location. So we need to shift that rocket trajectory vector over using this red vector here. That's going to require some vector addition. So that's what we're going to want to do for this challenge. And before I set you off on the challenge, I'm going to show you a handy way to keep our blueprints tidy. You see, everything that we want to do in Event Tick has to be connected by a wire, right? And as the number of things that we do increases, we're going to have this long string of nodes all connected, and it's going to become this big, long line of nodes, and that's going to get a little bit unwieldy. So there's a really handy node that we can use to organize things a little bit better, and that's the sequence node. Now, we can right-click and search for sequence, and we can get a sequence node this way. And if we hook up Event Tick to the input pin for sequence, we now have two outputs, then 0 and then 1. And if we hook up our draw debug coordinate system to then 0, then that's what's going to execute, is draw debug coordinate system followed by everything else that's connected to it. But what we can do is we can break this pin going to our debug arrow, and we can bring that debug arrow down. And then we can hook up then 1 to draw debug arrow. And now these two nodes will be executed in sequence. First draw debug coordinate system, then draw debug arrow. And of course, anything that's connected to these nodes will execute as well. Now, I'm going to go ahead and remove that draw debug sphere. As we saw, that was not the correct answer to this problem. So now our nodes are kind of stacked on top of each other like this. And the sequence node can have additional output pins added to it by clicking Add Pin. Now we have a then 2, and if we click Add Pin, we'll have a then 3, and you can always right-click on one of these and remove the execution pin to get rid of it. And this allows us to organize our nodes so that we don't have just one long string of nodes. So this is a nice tool that we can use to organize our blueprints. So now you have that additional tool under your belt. Now we also saw that this challenge is going to require vector addition. So how do you add two vectors in Unreal Engine? Well, it's quite simple. You can take any vector value, such as the one returned from getActorLocation. You can drag off and release to get the search bar, and we can use the plus symbol. And we'll see that under Utilities, Operators, we have this add function. If we select that, we get an add node that's designed to take two inputs of the vector type and output one vector, which is the result of vector addition. So we don't have to perform component-wise addition on our vectors. This node does that for us. But it's good to know what vector addition entails under the hood. So we can use vector addition to solve this problem. So it's time for your challenge. I'd like you to draw the explosion point. The explosion point is the result of vector addition. If we take our rocket trajectory and place its tail at our debug actor's location, our launcher, then the tip of that vector is the explosion point, right? So your job is to figure out how to calculate that explosion point. And then I'd like you to draw a debug arrow starting at the launcher debug actor and ending at the explosion point. Now, once you've done that, I'd like you to then draw a new debug arrow starting at the origin and ending at the explosion point. And that's going to fully represent this vector addition problem. We've drawn our arrows, we've calculated the answer, which is the explosion point, and we can see the geometrical significance of vector addition by placing that rocket trajectory such that its tail is at the head of the red vector, which represents our launcher debug actor's location. So pause the video, give this a try, and don't worry if you get stuck on this one. We're going to work through it together, and we'll get plenty of practice with these types of problems throughout the course. This is just to kind of get your mind working and get you used to figuring out problems on your own and seeing how far you can get. And if you're new to this sort of thing, it's normal to get stuck, to get frustrated. That's all part of the learning process. The important thing is that you just give it a try and see how far you can get. So pause the video and conquer this challenge now. Okay, so we know that we somehow need to perform vector addition, right? Let's think about how to go about this problem. I know that I have my launcher's location down here. I'm already drawing the arrow to it. And I have a rocket trajectory vector. If I add these two vectors together, then I know that the answer of that vector addition is the vector that starts at the tail of the red vector and ends at the tip of rocket trajectory, and that tip is the location of the explosion point. So I'm going to need to add two vectors together. I need to add the vector that is the location of my debug actor, and I need to add rocket trajectory to that. So let's do some vector addition. I'm going to take my launcher and get its actor location. I'm going to go ahead and just duplicate those nodes so I have it down here. And I'm going to add my rocket trajectory to it. So I can drag off, type in plus to get an add node, and I'm going to add my rocket trajectory. Now, we've been dragging variables in and using get to get a node for them, but a shorthand is to drag that rocket trajectory straight onto a node. And that's a shortcut for getting a get node. And now I have this quantity here, which is the vector addition. And I can draw a debug sphere at that location to see what that looks like. So I'm going to use draw debug sphere, and I'm going to draw this sphere. I'm going to make it red, so I'm going to select that color here and hard code red. I'm going to give it a radius of 10, and I'm going to hook in the result of vector addition of the launcher position plus the rocket trajectory vector. I'm going to hook that in for the center, and I want this to actually be executed. So I'm going to use my then2 on the sequence and hook that in right here. So let's see what that looks like. And I see my explosion point. That is the answer to the problem. That is where the rocket explodes. But let's represent these vectors with some debug arrows so we can better see what this vector addition problem looks like geometrically. I'm going to draw a debug arrow starting at the launcher and ending at the explosion point. So I want a debug arrow. I'm going to right click and use draw debug arrow, and I'm going to hook it straight up from draw debug sphere. Yes, I could create another pin on the sequence node, but I'm going to keep it right here just after draw debug sphere. And I want this arrow to start at my launcher's location. So I'm going to copy that here and hook that in as the start. And the end is going to be the result of vector addition. So I'm going to copy these nodes and paste them over here. I'm going to show you a way to organize this better in a second, but this is going to be the endpoint for my debug arrow. I'm going to give it a line color. This line color can be, let's make it blue. I'll give it a thickness of 2. and I'll give it an arrow size of 250. Let's play test and see what this arrow looks like, and there it is. So we now have the rocket trajectory drawn, but we've shifted it by adding the red vector to it. We've added our debug actor's location to it. So it starts at our debug actor's location and not at the origin. Now we've calculated the explosion point. Let's draw the arrow from the origin to the explosion point. And for this one, I am going to add a new pin so that we can have our next line of logic beneath this line of logic. So I'm going to draw a debug arrow. And I'm going to give it a new line color. Let's make it, say, green. Its line start is going to be the origin, and the end point is going to be the explosion point. That's the result of our vector addition. So I'm going to copy these nodes yet again, Control D, and hook those in for line end. And I'll give it a thickness of 2 and an arrow size of 250. And we'll hook this draw debug arrow up to that 4th pin on our sequence. So I'm going to drag it down here and hook it up and press play. And now we can see the green arrow. So we're now seeing the geometrical significance of vector addition here. And it's important to note the difference between a location vector and a direction vector. The red vector here, that's the location vector, the vector from the origin to the location of the debug actor. The blue arrow is our direction vector. That's our rocket trajectory, but we've shifted it over such that its tail is at the head of the red vector. And we did that simply using vector addition. We added our debug actor's location to the rocket trajectory vector. The result of that vector addition is the location of the red sphere. And we use that as the endpoint for the blue debug vector, which started at the debug actor location. And finally, we drew the location vector, that's the green vector, by starting it at the origin and ending it at the explosion point. Now, these 3 vectors represent the vector addition that we did. We took the red vector, the location vector of the debug actor, and we took our trajectory, the rocket trajectory variable. We added those together, and the result is the green vector, a location vector from the origin to the explosion point. And this is a very common example of the type of problem that you will encounter in game development all the time. You'll need to use vector addition like this in lots of different scenarios, and we'll get more practice as the course goes on. And you can always refer back to this example problem in the future when you have a similar problem to solve. So that solves our problem, but I'd like to go back to the level blueprint and zoom out and just show how unwieldy this blueprint is starting to become. This is a problem with blueprints. They can often become complicated, and it's important to get them under control. So the last thing we're going to do is organize this blueprint just a bit. I'm going to zoom in and remove the begin play node as we're not using it. So I'm going to get it out of the way by deleting it. And I'm going to move my draw debug coordinate system up here. And the next thing we're doing is drawing the debug arrow for DA launcher. These can in fact be connected to each other. I can break this wire and bring it up here and hook it up to draw debug coordinate system. So this is all one line of execution. Now I don't need 4 execution pins on my sequence, I only need 3. And we've seen that we can reconnect wires from one pin to another by holding down Control and clicking and dragging these. So I can hold Control and click and drag these so they're now connected to those pins. And I can right click on then 3 and remove that execution pin. So now we only have 3 execution pins. Now all of these nodes come next. I'm going to drag them back up here. And notice that we're reusing this quantity here multiple times. We're taking DA launcher, we're getting its location, we're adding that rocket trajectory to it and using that result. We're using it here, and we're using it over here, and we're also using it down here. Now we could store this value in its own variable. We could create a variable over here by clicking plus, and we can call this explosion point. And we can set that value. We don't have to give it a default value. We don't have to click compile and set its value here because we don't really know that value. We're calculating that value as the result of a vector addition. So what we want to do is set that value here in the event graph at runtime. We don't want to give it a starting value. We want to set that value as soon as we know it here once we've calculated it for the first time. So we can set the value of a variable in the event graph with a set node. If we drag explosion point onto the event graph and release, we know that we'll have two options, right? Get and set. We know what get is going to do. It's going to give us a node with an output pin. It's now time to see what set will do. Let's click on that, and here's the set node for a variable. We can set its value here, and as soon as our line of execution reaches this point, if we hook it on up like this, we know that explosion point will be set to whatever value we specify here. We can leave it unset, and it'll set to this default of 0, 0, 0, but that's not what we want. We want to set it to the result of vector addition. So I'm going to take this wire going into Draw Debug Sphere. I'm going to hold Control and click it so that I can disconnect it, and I'm going to hook it up to the set node. And now we're setting explosion point equal to the result of this calculation. And now we have access to explosion point, and we can use it and reuse it in our blueprints. Now I can take my explosion point, drag it out, get a get node, and hook it into center there. Now we're using it there, but also notice that the set node has an output pin, and that's just going to be the value of explosion point. So if we wanted to, we could hook that in directly. We could drag it straight across, and then we don't need an explosion point get node. That gives us the same result. But now that we have an explosion point, we can use it over here. Instead of performing this calculation all over again, we don't need to do that. We've stored that value in our explosion point vector variable. We can use a get node for it and hook that in instead. And the number of nodes has just decreased. And we're also not performing this calculation multiple times. We just performed it once and stored its value. Sometimes we call this caching the value. We're using that explosion point here in this debug arrow, but remember, we're also using it down here to draw this green debug arrow. We're drawing it with a line end of the explosion point. We don't need to perform the calculation all over again. We stored that value. We cached it off into explosion point. I'm going to drag it straight into line end to get a get node there, and now we're drawing that debug arrow. So I'm going to move our nodes up so that we can see them all when we zoom in. And now our nodes are a little bit more organized. Now we're going to be learning more methods to organize our nodes as the course continues. I don't want to bombard you with too many details all at once, as we've already learned quite a bit this lecture. But now this is what our logic looks like. And even though we've reorganized our code quite a bit, we'll still get the same result. If we press play, we'll see those vectors drawn onto the screen here. So we've learned a few key things in this lecture. We've learned that we can organize our nodes with a sequence node, which will execute these lines of execution one at a time. Now, there isn't any time passing between any of these. All of these happen in a single frame. They're in event tick, and every single frame, all of these nodes are executed very, very rapidly. You could think of them as being executed almost immediately. They're executed one after the other, but there is no noticeable amount of time passing from one node to the next. Computers are very fast, so these lines of execution are going to execute almost instantaneously. Now, in addition to the sequence node, we've also learned about how to add vectors. All we have to do is drag off of a vector value, type in plus to get an add node. And the result of the add node is provided by its output pin, which has a yellow color, indicating that it has the vector data type. And we also saw the usefulness of caching off values into variables. We created an explosion point variable in our level blueprint, and we only performed the calculation once and stored that result, and then we can reuse that value as we can get it since we stored it in the explosion point. And then we don't have to perform multiple vector additions just to get that same value every time. And the most important lesson here is we learned about vector addition and that we can treat locations as vectors. A location vector has its tail at the origin, but a direction vector is a different kind of vector. We can shift that vector so that its tail is anywhere in our level by adding that location to the vector. We added the location of our debug actor to the rocket trajectory in order to calculate the explosion point, which is the point starting at our debug actor's location and ending at the end of the rocket trajectory vector, having shifted that vector such that its tail is at the tip of the location vector for our debug actor. We're going to get some more practice with this type of problem in the videos to come. For now, great job. You got some excellent practice under your belt, and I'll see you in the next video.